Assalamualaikum and salam sejahtera. We are going to continue with 4.3 on isomerism. In this video, you are going to learn firstly, describe cis-trans isomerism due to restricted rotation about carbon-carbon double bond and carbon-carbon single bond in cyclic compound. Secondly, you are to identify cis-trans isomerism given the structural formula. Kita akan fokus pada stereoisomerism. Ia melibatkan isomers dengan same molecular formula yang sama dan same structural formula or same connectivity, but they have different arrangement of atoms in space. There are two types of stereoisomerism. The first one is called distereomer and the second type is called enantiomer. Distereomer has isomers that are not mirror image to each other. Enantiomer has isomers that are mirror image. Look at this example. Distereomers. This is the first type of stereoisomers. The first structure is not mirror image to the second structure. Whereas for enantiomers, the first structure is the mirror image of the second structure. Okay, the first pair distereomers are not mirror image to each other, but the second pair enantiomers are mirror image to each other. Let's learn more about distereomer. Distereomer is a pair of stereoisomers with structures that are not mirror image of each other. So the type of distereomers that we are going to learn is called cis-trans isomer, or another name for that is geometrical isomer. Cis-trans isomer exists in alkene, which has carbon-carbon double bond. This is the example of cis-trans isomer. Or it can exist in cyclic compound, like this example. Bagaimana kita nak mengenal cis-trans isomer? Okey, ada beberapa syarat. Pertamanya, mesti ada restricted rotation about carbon-carbon double bond in alkene seperti ini. Terdapat restricted rotation here, carbon-carbon double bond, ataupun di dalam cyclic structure in carbon-carbon single bond like this. We have restricted rotation here. Secondly, syarat yang kedua, there should be two different atoms or group of atoms attached to the carbon of restricted rotation. Contohnya dalam alkene di bawah ini, kita ada carbon yang pertama of restricted rotation. This carbon ada dua different group bromine hydrogen. Carbon yang ini pun ada dua chlorine and hydrogen, two different group. Untuk cyclic structure, carbon ini mempunyai dua group, different group hydrogen and bromine, and this carbon also have hydrogen and chlorine, two different groups or atoms. Next, syarat ketiga, compound itu mesti ada two substituents other than hydrogen, selain dari hydrogen. Contohnya untuk alkene, these two, bromine and chlorine, are the two substituents other than hydrogen. And for cyclic structure, also we have bromine and chlorine, two substituents. Let's look at what do we mean by free rotation and single and restricted rotation. Free rotation means this structure, the first structure is the same as the second structure because of putaran bebas. Restricted rotation make the first structure alkene ini tidak sama dengan the second structure. Putaran terhad pada carbon-carbon double bond menyebabkan struktur ini tidak sama. Mereka adalah dua struktur yang berbeza. Example. Can two butene form cis-trans isomers? Let's draw the structure. Yes, it can form. We can draw like this and another isomer like this. Check whether they can form cis-trans or not. Here we have carbon-carbon double bond of restricted rotation. Each carbon of restricted rotation has two different groups attached to it. Two different groups attached to it. So requirements are met for cis-trans isomer. The same goes for the second structure. The first isomer is called trans 2-butene because the substituent is on the opposite side. Opposite side. And the next structure, the next isomeric pair is called cis-2-butene because the two groups are on the same side. Another example of cis-trans isomers on cyclic compound. The first structure is named cis-1,2-dimethylcyclohexane because the two groups of atom here are on the same side. Whereas its isomeric pair is called trans 1,2-cyclohexane because the two substituents are on the opposite side. If one of the doubly bonded carbon has two identical groups, geometrical isomerism is not possible. So we have two identical groups on the same carbon. So cannot be cis-trans isomer. This structure also cannot be cis-trans isomer because you see that this carbon has two identical groups attached to it. This carbon also has two identical atoms attached to it. So they are not cis-trans isomers. Let's do this question together. Which of the following compound can exist as pairs of cis-trans isomers? For part A, we must draw the structure in two-dimensional first, and we get the structure. And then check whether it meets the requirement for cis-trans. This is not cis-trans isomer because there are two identical groups of atoms attached to the same carbon. For part B, it is cis-trans isomers. Because when we draw the structure, the two identical groups of atoms attached to the same carbon. For part C, it is not, it is cis-trans isomers. Because when we draw the structure, the two identical groups of atoms attached to the same carbon. For part D, it is cis-trans isomers. Because when we draw the structure, the two identical groups of atoms attached to the same carbon. For part E, it is not we get this structure. And the first isomer pair is called cis-isomer because the two substituents are on the same side. Whereas for this isomeric pair, it is on the opposite side, so it is trans isomer. Question 2. Which cycloalkane shows cis-trans isomerism? Okay, for part A, there should be a H here and H here. And we check that on this carbon of restricted rotation, there are two groups, two atoms, different atoms. So it is cis-trans isomer. It can form cis-trans isomer. So the structure, the isomeric pair can be drawn like this. Okay, the first structure is cis, since it is on the same side. And the second structure, opposite side, is trans isomer. Part B is not cis-trans isomer because it has two identical atoms attached to the carbon of restricted rotation. So it is not cis isomer. In this video lesson, we have learned about one type of stereoisomerism, which is cis-trans isomerism. We also learned about requirements of the cis-trans isomerism in alkene and cyclic compound, and we also learned how to identify cis-trans isomers. In the next video, we are going to learn more about another type of stereoisomerism, which is enantiomers. That's all for now. Thank you.